Hi there everyone. Welcome to the video lecture series on complex integration. Let us take up another type of a question over here today that where we are asked to evaluate the integral over the curve C, then the function is z square minus z plus 2 dz from 0 comma 0 along the curve parabola C given as y equals to x square. So let us see how to do these kind of questions, and let us start solving it. So the first thing over here, in this question, everything is pretty much straightforward given to us. So as we had seen in our previous question, that in the first step we can find the, either we can go about the curve or we can take up the points. Now over here the points are already given, so basically these are the points for the limits. Okay, so for the limits we are already given here the points as origin O 0 comma 0 and another point A, let's call it A 1 comma 1. These are already given to us. Now let us find dz. So step number 2 is to find dz. Now finding dz can be done in multiple ways or different ways also, but now here as the most easiest way is, let z equals to x plus iy. Therefore dz is equals to dx plus I dy, and we have seen this as an important formula in our one of the first video lectures, and this dy we need to find. We can find either value of dx or dy, we can find it using the curve. Also we now know that also y is equals to x square. Therefore dy by dx is 2x. Therefore dy is equals to 2x dx. Okay, so this is the few important findings that we have done. So let us call this as the first, this is the second important thing that we have, the third important thing. Okay, now from first and third, okay, we can see that we can interpret from 1 and 3. We have dz equal to dz, which is dx plus I dy. Dy is now become 2x plus 3. Okay, so it is 2x, sorry, dy is 2x over here, 2x dx, so it will be now here. Therefore dz is equals to dx plus, instead of writing dx we will write this way. Yeah, we'll write it as we'll take dx common on the right side, so it will be 1 plus I 2x dx. That would be better. So this is the fourth important finding that we have. Now let us simplify the function that we need. So step number 3 is basically simplifying the function. Okay. Step 3, simplify fz. Okay, now this simplification of function, it's very important because that will help us to understand why how the function is going to you know separate into the real part and the imaginary part. So let us do that. F of z is equals to, I'll just break up a partition over here so it's better to go with. So f of z is equals to z square minus z plus 2. So we already now have z can be written as x plus iy. So x plus iy the whole square minus x plus iy plus 2. Now this y can be written as x square. So x square minus x plus x plus I x square the whole square minus x plus I x square plus 2. This is to be done. Now see, here it's our call whether you want to expand the function or you don't want to expand the function. In either case the answer is going to be there, but I would prefer here a little bit of simplification to be done, because further we may need it. So let us we can even keep the answer over here, it's not wrong, but simplification would be a good option. So I'll just expand the whole thing, so it will give you x square plus 2x cube I, okay, and then it will give you I square is minus 1, so minus sign will come and x square becomes x raised to 4, okay, minus of x minus of I x square plus 2. So simplifying these terms, you will get over here x square minus x raised to 4 minus of x plus 2, and let's take I common, then it is 2x cube minus of x square. This is what we get. This is the function over here. Now this function, uh, we will call it as, let's call it number 5. So now this function is maximum we can go up to. Now let us go for the simplification. So step number 5, step number 4 will be integrating or solving, integrating f of z. So let us do that, or solving of f of z. So the integral which is given to us, so that will be I equal to integral over f of z dz. Now here don't write the limits immediately, let us see what happens to the function. First we have this term x square minus x raised to 4 minus of x plus 2 plus I times 2x cube minus of x square. Now this is the function. What about dz? dz is 1 plus 2ix dx, okay? So we have another term coming here, 1 plus I times 2x dx. Okay, and as we see the variable of integration is x, so we will write the limits of x. So the limits of x, if you can see from the step number 1, it is x is going the from origin, the x coordinate is 0, and in the point A the x coordinate is 1. So the limits of x are going to go from 0 to x equal to 1. Now a simplification over here is required, because what is happening, the function itself is having the real part and imaginary part, and 1 plus 2ix which came from the dz, that is also having a real part and the imaginary part. So we will need to multiply this and get the whole thing done. So let us do that. So on multiplication here we will have x going from 0 to x equal to 1, okay, that's not an issue. But then here we will when we multiply here, see this entire chunk gets multiplied, this full function will get multiplied with the 1. So that means the entire function will come back. So I'll have x square minus x raised to 4 minus of x, okay, plus 2 plus I times 2x cube minus of x square. That's it. Now when I multiply this I 2x into the function, what I'll get, I will keep it common, outside rather, and this 2x I will multiply to the function. So what happens here, I will get is 2x cube minus of 2x raised to 5. Then here I will get minus of 2x square, okay, and then here it will become plus of 4x. Okay, now here when I see, when this 2ix gets multiplied with this whole term, what I get is I square will be there. So I square will give me the value of minus 1. Okay, here I will get minus 1. So the negative sign will come into the picture. Okay, and this 2x gets multiplied into the bracket. So I will have, here it will be 4x raised to 4, and then here it will be minus of 2x cube, and then there will be dx. Okay, this full function will have dx as the differential. Okay, now this is very easy. So we have got the real part, we have got the imaginary part, if you can see it clearly. So let us now just start integration. We just have to do the integration carefully and we are through. So yeah, as I have told you, you can do this integration part by part in your calculator and write the answer directly. That is also not a problem, but let us do the traditional way to have a sense of appealing or sense of completing the whole question. So over here, when we do the integration, in the first part we will get the integration is x raised to 3 upon 3, then there is x raised to 5 upon 5, then there is x square over 2, then there is 2x. This is the first part, that is going from 0 to 1. Then there is I times, here I will get, now there is 2x raised to 4 upon 4 I will get, so it will become x raised to 4 upon 2. Then there is x cube upon 3. Okay, then this is also going from 0 to 1. Then I have over here, it is I times 2x cube, right? So 2x cube integration is going to again be 2x raised to 4 upon 4, which is nothing but x raised to 4 upon 2. Here it will be minus of 2x raised to 3 over, sorry, not 3, it will be uh, 2x raised to 6 upon 6. So that will give me, it will be x raised to 6 upon 3. Okay, and then here I will have 2x cube over 3 plus 4x square upon 2, that will give me 2x square, and that goes from 0 to 1. And here I will have, with the negative sign, I have 4x raised to 5 over 5 minus 2x raised to 4 upon 4, so that is x raised to 4 upon 2, 0 to 1. Okay. Now, now let us complete up the whole fraction part. So here we have I, capital I, the integral equal to 1 by 3 minus 1 by 5 minus 1 by 2 plus 2. Rest all terms, when you substitute the lower limit, they become 0, so not an issue. Then plus I times 1 by 2 minus 1 by 3. Here we have plus I times, I'll just write it at the lower part because it will make it otherwise very much congested. I'll just write here. Yeah. So plus I times 1 by 2 minus 1 by 3 minus 2 by 3 plus 2. Okay. And then there is this minus sign is there, and in its minus sign we have 4 by 5 minus 1 by 2. Okay, now let us simplify all these expressions quickly. So we have 1 over 3 minus, just a minute, I'll do this quickly. So for the first part we will have something like 49 by 30. Okay, and no, not 49, yeah, 49 by 30. So see, the LCM over here is 5 3s are 15, and here it is 2. So let us just simplify. Here let's see. We'll do the simplification here. Oh. So here we get is 5 3s are 15 and 2s are 30. So here we will have 10. Here it is 30, right? So it is minus of 6. Here it is 2, so it's going to be minus of 15, and here it is nothing, so that is 60. Then here it is going to be I times 3 minus 2, that is 1, and here it is 1 by 6, plus I times, here it is going to be uh, minus 3. Minus 3 is 1, and then there is half, so minus 1, so it's half and plus 1, so it is 1.5, so that's going to be 3 by 2. 3 by 2, and here it's going to be, so the last part it's going to be uh, it is 10, right? So 8 minus 5 is 3. Here it is going to be 3 by 10. So let's simplify this a bit more, and this will give you, I guess it's 60 70 70, right? 70 minus of it's 21, so it's 49. That's what we were getting, 49 by 30. And here it's going to be, yeah, 49 by 30 minus 3 by 10 plus I times, here it will be 9, right? So 9 by 6, no, 9 by 6 plus 1, so 10 by 6. Okay, and yeah, so this will be, this is 39, 940 by 40 by 30, so what is it, 4 by 3 plus I times 5 by 3. That's the whole answer for our question. So 4 by 3 plus I times 5 by 3 is the answer for our question. I hope you have liked it. Now see the whole process of integration which I have done over here at the last some steps. Okay, this could be omitted easily. Which all steps could be omitted? Let me show you. I'll just highlight it with this. Let me give it a purple color. After this step, okay, the integration, this step, 1, 2, 3, 4, and 5. Yeah, 5 is the final answer. So 4 steps could be omitted if you are allowed to use calculator. Otherwise, you need to do the manual calculation. And so here you get this as the final answer. I hope you have understood this problem, because here for the first time we have taken the curve as a parabola. Okay, so please go through the entire question, and I hope you liked it. Please hit like button and share it with your friends, those who find the topic important or those who have it in their syllabus. Till then, keep solving good amount of mathematics. I am Mayur Gohil. I'm signing off for the day. Thank you.